Cream is cream with a whole lot of gas involved in a lot of gas involved in this little bit of liquid here. If you need to move up or see a little better, that's okay. We'll put the lid on, seal that up,
It's gonna explode, isn't it?
turn on the bell jar. What we're doing in here is decreasing the pressure inside this jar. As the pressure is decreasing, what's the volume of the gas going to do? Expand.
That's it?
Oh, it's going.
It's gonna explode. I'm ready for this.
What's rising? The shaving cream. And why is the shaving cream rising? Because it's expanding its volume. Why is it expanding its volume? Because there's less pressure on it. Less pressure, volume increases. See it? I have less pressure inside this jar, a lot more pressure on the outside, so my volume of my shaving cream or volume of my gas has increased. What's going to happen when I open up this knob and let the air pressure back in? As I let the pressure back in, the volume is going to decrease. Should decrease. Can you hear it come out? I'm letting the air pressure back in. It's still stuck there. There's too much pressure pushing down on this jar from the outside. I can't even lift this jar off yet. There's so much air pressure on that jar at the moment. Now I can lift that jar off. I really was trying to. And we've increased our pressure, so our gas volume decreased. I'm going to carefully pour some liquid nitrogen into my container here.
I was about to say stop going. Is that healthy for us?
Oh, it's breathe. It's just nitrogen. It's just a liquid in there. It looks like a clear liquid.
Nitrogen in there. It's fine.
Yeah.
You never know.
Really?
Plow did this with balloon animals, and then he killed them.
Wait,
So
what?
yeah,
Plow
Plow did this with balloon animals, and he accidentally popped them because he left them in too long.
This is extremely cold, so I don't want to touch it with my hands. I'm going to take a balloon. Right now its volume is
Constant,
quite a large volume. I'm going to place it not into a warmer environment, but into a
cooler.
colder. In a colder environment, because of the direct relationship, as temperature goes down, the volume should also go down.
Don't touch it.
It's in the bottom. It's a liquid. The H2O gas I'm not worried about. It's the H2O liquid I'm worried about.
What?
Sounds like when they put your
I'm just going to close it for a quick second. Nothing magic happening in there. Just trying to get the liquid nitrogen around the balloon. Science. Oh, it's going. It's going. Just cold in there. Really cold. Really, really, really cold. How cold? I could look that up for you. I don't know.
Oh yeah, I know what this is.
snow there.
Around -200 Celsius.
This one's
Oh, that's
not
pretty warm.
This one is not.
What happened to my volume in that cold environment? Decreased. Now it's warming up in the room temperature environment. What's happened to our volume? As temperature increases, volume increases. As temperature decreases, volume decreases. You seeing those?
Yeah, let's do it again.
Direct relationship. Again, sure.
Just put your can in there.
They also have your head for
That's not sealed.
Mr. Cloud's done some racquetballs before.
I don't think so.
You take those racquetballs and you slam them against the ground and they shatter because they don't have their elasticity anymore.
That's all banana.
Banana too, yeah. Easy one to show, yes?
The science department should find a way to do some super cold water. That one's really cool.
Temperature decreases, volume decreases, temperature increases, volume increases. Direct relationship. Dry ice is carbon dioxide in the solid state, and it's sublimating. I brought some in earlier this year. it's going from a solid to a gas directly. It's not going to the liquid state. You have to change the pressure to make it go to a liquid state. As it goes from a solid to a gas, we're increasing our gas molecules or moles. Instead of a balloon, I'm going to use a little glove here. What we're keeping constant in Avogadro's law, and yes, it's the same Avogadro who came up with 6.02 e to the 23rd, same guy. Sorry. We're seeing we're dealing with the number of moles and the volume. So as the solid becomes a gas, the number of gas molecules is going to increase. We're making more gas molecules. Moles of gas are increasing. As our moles of gas are increasing, what's going to happen to the volume of that glove?
Decrease.
What's that glove doing as our moles increase? We make more gas molecules inside the glove.
It's inflating.
It's inflating, which means our volume is going
Up.
up. We're seeing yet again a direct relationship. As one increases, in this case the number of moles, we see the volume also increases. If I decrease the volume, I have to decrease the number of moles as well. If I had here 22.4 liters of gas and I had 1 mole of gas, that's a constant, and I raised it to 2 moles of gas, what would I expect my volume to do? Double up to 44.8. Dry ice I probably won't have tomorrow, liquid nitrogen I probably won't have tomorrow, but the other demos I